This is a differential equation class, and we're solving a problem from section 3-1, and it's going to be problem number 5. It says that y prime equals x squared y. Now, because we're in section 3-1, we're going to write that y prime minus x squared y is equal to 0. We're going to remember that the series approximation for y is summation n equals 0 to infinity a n x to the n, and y prime is going to be summation n equals 1 to infinity n a n x to the n minus 1. Okay, so we're going to substitute those summations into our equation. We have summation n equals 1 to infinity n a n x to the n minus 1 minus x squared summation n equals 0 to infinity a n x to the n is equal to 0. Okay, the next thing I'm going to do is bring the x squared term into the summation sign. So I'm going to have summation n equal 1 to infinity n a n x to the n minus 1 minus summation n equals 0 to infinity a n x to the n plus 2 is equal to 0. Alright, well, now I want the exponent to have the exponent of the x term to be the same in both summation signs. So we'll do a substitution of n is equal to n plus 1 in the first summation sign. That'll give us x to the n term. And then we'll do a substitution x, not x, n is equal to n minus 1 in the second summation, so I get an x to the n there. So that's my plan. So I get summation. Now if I put a n plus 1 in here for where the n is, I get n is equal to 0. Summation n is equal to 0 to infinity n plus 1 a n x to the n plus x minus 1 minus summation n equals, if I put an n minus 2, the minus 2 becomes a plus 2 when I put it on the other side of the equation, a n minus 2 x to the n is equal to 0. So the purpose of doing that is so I can put it under one summation sign. Wouldn't it be nice if I did that right? And so now I see that I have an n equals 0 term over here and an n equal 2 term over there, and I see that I failed to make this n plus 1 there. All right, now that I've corrected my mistakes, both of them that I made in the first term, I can now proceed and take out the n is equal to 0 term and the n is equal to 1 term out of the first summation sign. Then it'll start n equal 2 to infinity, and then I can just put both of them inside the same summation. And that's what I'm looking to do, so I can find a recurring formula. So when n is equal to 0, I have a1 x to the 0, which I'm not going to write. And when n is equal to 1, I have 2 a2 x plus summation n is equal to 2 to infinity of n plus 1 a n plus 1 minus a n minus 2 inside a bunch of brackets, and x to the n is equal to 0. Now, because it's a differential equation, we know we have to have initial conditions, so a0 is arbitrary. But due to the nature of the power series, each of the exponents of the n of the x terms have to be 0 individually. So the x to the 0 term that's sitting right there has to equal 0. A1 has to be 0. I have no other choice. The x to the first term, which is sitting there, 2A2, also has to be 0, which implies that A2 is 0. Then I've got a recurring formula sitting there, and I can write my recurring formula, which has to equal 0. And my recurring formula is an plus 1 is equal to an minus 2 divided by n plus 1. And then I go on to say the summation starts at n is equal to 2. So this is true for all n greater than or equal to 2. I can't put an n of 0 or an n of 1 into the recurring formula. That wouldn't make any sense. So I can't do that. All right, so recapping, A0 is arbitrary, A1 is 0, A2 is 0. For n is equal to 2, I'm looking for A3. So when n is equal to 2, I'm looking for A3. That's going to be A0 divided by 3. When I look at A4, I get n is equal to 3. So I'd be A1. Well, A1 is 0, so A4 has to be 0. When I look for A5, n has to be 4. A2 is 0, so that term has to be 0. Okay, now I look at n is equal to 5. When n is equal to 5, I have A6. A6 is going to be A3. A0 over 3 divided by 6. I'm going to write that as A0 divided by 3 times 3 factorial. Okay, I then look at A7, and I find that to be 0. I look at A8, I find that to be 0. I look at A9, so n is equal to 8, and I have A9 is equal to 8 minus 2 is 6, so it'd be A6, A0 over 3 times 3 factorial. Well, that's 2 3 factorial, isn't it? 2 times 3 factorial divided by 9. Okay, so I'll write that as A0 divided by 3 factorial times 3 squared. Is that what it is? Yeah, there's 3 times, I don't know. 2 times 3 factorial. No, this is 3. No, I was right the first time. 3 times 3 factorial. So 3 times 3 factorial. I guess we're just trying to be smarter than we are. So we're just going to call this 18. And we're going to call this 18 divided by 9. And we're going to call that, what are we going to call it? $162. over 162. All right, well that's fine. All right, and if I continue, I'd have A, and then I could come up with an A12 if I wanted to, but I don't really want to. So I'm going to write down a final answer, and I'm going to say y of x is equal to A0 plus A3, which is A0 over 3 x cubed, plus A6, which is A0 over 18 x to the 6, plus A9, which is A0 over 162 x to the 9th. All right, now at that point we're almost done. We need to check our work. So there's no way we can know that's right unless we check our work, or we look in the back of the book and we know what the answer is. So we're going to check our work. Y is A0 over 3x cubed, A0 over 18x to the 6, A0 over 162x to the 9th. Y prime would be A0 x squared plus A0 over 3x to the 5th plus A0 over 18x to the 8th. And that's as many terms as I have. I want one of these guys and minus x squared of those guys, and when I get done I best have 0. So that's my plan. So I have minus x squared A0, x squared A0. I've got a minus A0 over 3x to the 5th plus A0 over 3x to the 5th. I have minus A0 over 18x to the 8. That guy goes away. If I had another term, they'd go away too. Close enough. And my problem checks. Okay, we're going to do one more thing before we call this problem over. We're going to put it in Maple and ask for the series solution to the differential equations. So in Maple, there is an assistant and there's an ordinary differential equation solver. And so we're going to put in an equation. We're going to have y of x and a first derivative, and we're going to have y of x, no derivative, and then we're going to say the first derivative is equal to x squared times the original function, which is the original problem. So now I have it. I'm going to solve it symbolically, and I didn't save the equation. Wasn't that cute of me? Okay, so I'm going to do it again. Y, x, first derivative, insert, no guy, insert. I have an equal sign, minus x squared times, I'm going to add it, and now I see that it's the same equation that the book has. Isn't that convenient? I'm going to solve it, and I'm going to solve it using a series, and I'm going to truncate it off to order, well, we better go up to order 9 in order to see the terms that we had. 9, and then we're going to solve it. There we go. So there we go. 1/3 y0. Oh, there's a0. What? I have a minus 1/3? How did I mess that one up? Let me go back. No, there's no minus sign there. Edit. And so we're going to edit the equation. Going to get rid of the minus sign. Well, we were too exuberant on having the right problem. And now we're going to go up to, we're going to go up to 12 because we want to see the ninth guy. 12. And wait for Maple to do what it's supposed to be doing. Have it show the Maple commands. There we go. And now we have 1 over 162, 1 over 18, 1 over 3, exactly what we had. We're going to go and put the Maple commands back into Maple. And that way, so if I do that and go to this guy here, which makes it bigger, I can then have my answer be a little bit bigger. Okay, good enough? Okay, that ends the video on problem number 5.